Good morning, students. This is Mr. Mace, and we are here to talk about fractions again today. This is more specifically Unit 3, Lesson 8, and we're going to be dealing with pages 135 and 136 in your workbook. So if you could take those two things out and get prepared for the rest of this lesson, that would be great. Going to make our jobs a lot easier. Now, I know that you've already spent some time working with fractions this year, and so this should be somewhat review. Hopefully, as you learned or went through your other lessons, you realize that there are a lot of things in dealing with fractions where we need to have, or it's much easier to have, a common denominator. Two of those things are adding and subtracting of fractions, and in that case, we have to have a common denominator. There is no other option. If I don't have a common denominator, I can't solve the problem. So that's a mandatory one. But even in comparing of fractions, it definitely helps to get to that common denominator. That's by far the easiest way to determine which fraction is larger, is to make the denominator the same. So we're going to start with some adding and some subtraction problems, but in all, the number one thing we are trying to establish here, I'm pretty sure you guys know how to add and subtract at this point, but the biggest thing we need to do is how can we create common denominators? What are some of the ways that we can create common denominators? Okay, so as we look at case number 1 here, it says denominators with no common factor other than 1. Okay, or except 1. That means if I look at the factor list for 3 and the factor list for 4, the only numbers that I can find in those two lists that are the same as 1, and that doesn't change my denominator at all. So in this case, I just have to multiply the 3 to the 4 and come up with my common denominator of 8. So as I look over here to the example, okay, I can see that I started with 2/3. And I multiplied both the top and the bottom. Notice how we are treating these fractions equally. Whenever I change the denominator, I must also change the numerator by the same amount. So if I multiplied by 4 on the bottom, I must also multiply by 4 on the top. And that's going to take me to this fraction right here. That's going to replace my original fraction of 2/3, and I'm going to change that to 8/12. And in the second fraction, the one I started with 5/4, or 5/4, I multiplied both of them by 3 to make my denominator 12. And to get from that one to that one, I created 15/12 as my answer. So that's my new problem. That's the solvable math problem that they give me now, is 8/12 plus 15/12. Now, as I add those two things together, I should notice that I end up with what we call an improper fraction, or a fraction with a larger number on the top than on the bottom, or a larger numerator than denominator. And if that's the case, this is an acceptable answer. It's the correct answer, but it's not the best answer. We always want to try to simplify. We always want to try to put it in the most the easiest way for us to decipher these types of problems. So we want to then convert this into a mixed number. And we do that by dividing the numerator by the denominator. Or we do that by pulling out as many groups of the denominator as we can. So in this case, the denominator is 12. So as I look at 23, I want to see how many times can I pull 12 out of 23. How many groups of 12 can I pull out of that? And in that case, I can pull one full group out, which is where the 1 comes from, right here. And then what is left over? After I do that division, after I pull that group of 12 out, what am I left with? And in that case, I'm left with 11, which is our new numerator. And the 12 stays the same. The denominator will not change in that instance. Okay, so that's all they're showing you in that example there. Pretty straightforward stuff. And we have a couple of examples down here at the bottom. To me, again, the adding portion of this, the converting from an improper fraction to a mixed number, that's not the important part of today's lesson. I just walked you through their example there. But the more important part is, what is our common denominator going to be? So as I look at problem 1, it's an adding problem, 4/5 plus 2/3. Okay, I've got to determine what number can both 3 and 5 go into that I can change those into. Okay, and as I look at them, again, just like the case 1 problem, I can't find any common numbers, any common factors that I could multiply those two numbers by that aren't themselves. The first ones that we come across would be multiplying them by each other, so 5 and 3. All right, so as I'm looking here, I like to rewrite it just so I can kind of put it in my perspective here. So I've got 4/5 plus 2/3, and I want to multiply these two denominators together to make my new denominators of 15. So I can actually even solve this problem. As it stands right now, I still can't solve this problem. Now, when we create common denominators, or when we go through this process, essentially what we are doing is we are creating equivalent fractions, which is what you worked on, I believe, yesterday in yesterday's lesson. All right? And when we're multiplying by each other's denominator, all we are simply doing is taking the denominator from the other fraction and multiplying it by our other fraction. So in this case, I'm multiplying the 5 by 3 on both the top and the bottom, and I end up with 12/15 on the front side. And how did I get from 3 to 15? I multiplied by 5, both the top and the bottom on this side, and I end up with 10/15. And so my new problem after I go through this process is 12/15 plus 10/15. All right? Now, if we look at the directions here, it says add or subtract. If the answer is equal to or greater than 1, write the answer as a whole number or a mixed number. Okay, so they want us to convert this. They want this to be a process like they did in the previous example. We can't just leave it as that improper fraction that we said was an acceptable answer. It's an okay answer. They want the best answer right now. So as I add straight across, okay, I've got 12 plus 10 is 22. And the 15 stays the same. That's why we make that common denominator, so we don't have to change anything on the bottom, and we don't have to try to determine what that denominator should be. We know it is 15. Now I'm looking at this and saying, how many 15s can I take out of 22? Well, that's a pretty easy one. Those numbers are pretty close together. So I should again see that I'm pulling one whole group of 15 out of there. And what am I left over after I pull those away? In this case, I can simply subtract 15 from 22 and realize that I have 7 remaining after I pull that group of 15 out, and the denominator doesn't change. So my answer for number 3, or number 1, I guess, is 1 and 7/15. All right, well, the same rule applies for subtraction problems. Again, I know you know how to subtract. I know that's not the issue. The bigger issue is, can we make that common denominator? And another hint for me that I tell my students every year is if the denominators are only one number apart. I could go through the whole process of checking, well, can 5 go into anything? Can 6 go into anything? If my denominators are one number apart, like they are in this question, 5 and 6, it's automatic. The only way I can come up with a new denominator is by multiplying those two denominators together. So I'm going to scroll up here just a little bit just to give myself a little bit more room. So we have 3/5 minus 1/6. I know that the only way I can make a new denominator, because they are one apart from one another, is to make that denominator 30 by multiplying the 5 and the 6 together. Now, how did I get from 5 to 30? I multiplied by my opposite denominator, right? I multiplied by 6. Because I'm creating equivalent fractions, I have to treat the numerator and the denominator equally. So 5 times 6 is 30. 3 times 6 is 18. So what I'm looking at here is 18/30ths in the front part of my problem. And how did I get from 6 to 30? I multiplied both the top and the bottom by 5. And this one becomes 1 times 5 is 5/30ths. All right, so my new problem becomes 18/30ths minus 5/30ths equals whatever 18 minus 5 is, which in this case is 13, over my common denominator of 30. Now, we might need to simplify, we might need to look to simplify, but if I found that least common denominator, if I found that smallest number that they both go into, my denominator will, or my fraction should be in simplest form already. Okay? All right, so now there's another couple of ways we can do this. And one of it, basically what it boils down to is, do I want to do more work at the beginning of my fraction, or do I want to do more work at the end of my fraction problem? And it doesn't really matter. I'm not disparaging either way, but the top solution, Roger's solution, he's handling it by saying, I want to find that smallest common denominator. I want to do my work up front at the beginning, find my simplest, or my LCM or my LCD, the lowest common multiple, the lowest common denominator first, and then I know I'll have my simplest form answer. Whereas Serena, on the bottom, she's looking at saying, I want to just get my new fraction. I want to make my common denominator of 24 by multiplying those two denominators together. But then I'm going to have to simplify on the back end. I'm going to do more work at the end. Once I change my fractions, I find out I end up with 38 over 24. And when I make my 1 and 14/24, I know that those are both even numbers and I can divide them both by 2. So there's just one extra step on the back end. Whereas if we take the time to realize and skip count by 4 and 6, 4, 8, 12, 16, and if we go to the next round, we see 6, 12, and 18, we're looking for that first number we come across where both of them are. That is where our 12 for our denominator comes in there. Okay, if I continue this pattern, I'm going to also see that 24 pops up. So if I continue with my 4s pattern, here's 20 and here's 24. And as I go with my 6s, I've got 6, 12, 18, and 24. So I still will run into a common denominator there, but it's a little larger number, which means I will eventually have to simplify on the back side or on the bottom part of this. All right, so it's just a matter of, do I want to simplify first, so to speak? Do I want to find that lowest common multiple, or do I want to just multiply the two denominators like I've been doing and then simplify when I'm done? Either way is perfectly acceptable. All right, so let's take a look at these two questions here. Again, it says if the answer is equal to or greater than 1, they do want us to answer as a mixed number or a whole number. Okay, 6 and 8. I personally like to get my work done early. So that's the way I like to handle this. So I'm looking at 6 and 8 as my numbers. I like to skip count and actually write the numbers out here so I can see how these numbers play out for me and see where I come across that common denominator first. So in this case, if I'm skip counting by 6s, I'm skip counting by 8s, the first number I come across in both lists is 24. So I know that my denominators are going to be 24. Oops, not a 12, 24. Change this out here. I could make it 48. If I go with Serena's method, I could make it 48, but that's something where I have to do more work on the back end. Now, how did I make my new numerators? Because I can't just change the denominator and think that I'm done. So in the 5/6 problem, okay, how did I get from 6 to 24? I multiplied by 4. That means I need to do the same thing on the top of this fraction. So 5 times 4 is 20. All right, how did I get from 8 to 24? In that case, I multiplied by 3. So I have to do the same thing to the top. 3 times 3 is 9. So my new problem is 20 24ths plus 9 24ths, and that will get me to, this is an adding problem, 29 24ths. They said they wanted their answer in whole numbers and mixed numbers, which means I need to figure out how many 24s can I pull out of, how many groups of 24 can I pull out of 29. Again, the numbers are nice and close, so one whole with 5 leftovers, and I keep my denominator the same, 1 and 5 24ths. All right, same thing on the bottom here. If I skip count by my two numbers, skip count by 9s, skip count by 6s, I'm going to find that my common denominator, the lowest common denominator, is actually 18. Could use 36. Both 9 and 6 go into 36. I could go to all the way to 54 by simply multiplying the 9 and the 6 together. Either one of those are acceptable answers. I want to do my work up front. I want to go with Roger's method, Roger's solution up top there, as opposed to Serena's. I don't like to do the subtracting or the minimizing, the simplifying, on the back end. All right, so how did I get from 9 to 18? I multiplied by 2, which means I need to do the same thing on the top here. Multiply that by 2. I'm kind of running into each other here, so just try to bear with me. 5 times 2, my new problem, or new fraction at the beginning of this problem, is 10/18. This is a subtraction problem. How did I get from 6 to 18? I multiplied by 3, which means I need to do the same thing to the top to make my new one here. That's also multiplied by 3, so 1 times 3 is 3. And so my new problem is 10/18 minus 3/18. And when I end up with that, 10 minus 3, is 7, and the 18 stays the same. Because I did my work up front, I know that that is the simplest form fraction. I know that that's the smallest fraction I can have that is equivalent to what I'm working with here. All right, so this is your first video. I'm going to pause here for a second. What I would like you to do, guys, is I would like you to take a look at page 136, and before I go through a handful of problems here, I would like you to try page 136 as best you can on your own. You don't need to do them all, but maybe pick a couple questions and try to practice it, because we also have some mixed numbers in there that we need to try to solve. All right, I will be going through that explanation in the next video, and so hopefully you can check your answers against what I put on there for that.